Section 7.7, Intermediate Algebra, we're going to take a look at the distance formula, which is a derivative from the Pythagorean theorem. It states that the distance between any 2 points, given the coordinates here, is given by the following formula. We'll let the distance between the points stand for d. It's found by taking the difference between the x coordinates of the 2 points squared plus the difference between the coordinates of the y of each of the points, and that difference squared. Furthermore, the distance formula can be used to verify a formula for the coordinates of the midpoint of a segment connecting 2 points, and the midpoint formula, I'll abbreviate it as MP, is found by basically averaging the x coordinates of the endpoints, in other words, adding the 2 x coordinates and dividing it by 2 for the x coordinate of the midpoint, and doing the same thing with the y coordinates of the 2 points on the line segment. We'll add them together and divide by 2. Let's look at an example of how those formulas work. In this problem, they're asking us to find the distance and the midpoint for these 2 points. And just to have a little frame of reference, let's do a kind of a rough sketch of what this looks like. So we have the point -3, 5, and we have the point 4, 6. So here's our 2 points, and they're asking us for the distance between these 2 points, which the formula, as I said, is a derivative from the Pythagorean theorem. And if you look at the horizontal distance between the 2 x coordinates and the vertical distance, since horizontal and vertical are at right angles to one another, we have a right triangle, and we're looking for the distance in a right triangle. That distance between these points would represent the Pythagorean theorem. So you can see where the basis of this formula is coming from. Furthermore, just for reference, and it doesn't matter, but I'm going to call this first point the x1, y1, and the second point as x2, y2. Using the distance formula then, which was given as the square root of x2 minus x1 quantity squared plus y2 minus y1 squared, and taking the square root of that result. Plugging in the values, I assigned the x sub 2 for this x coordinate, so we'll start out with the 4 minus the -3, which is the other x value, squaring that difference, plus starting with the y that goes with the first x that we used. Here's my y sub 2 is 6 minus the y value of the other point, taking the difference and squaring that. Simplifying here, we have a minus, which is going to give us a plus. So 4 plus 3 is 7, and we still need to square that. 6 minus 5 is 1. We need to square that. 7 squared is 49 because of 7 times 7. 1 squared is 1. And final simplification, we have the square root of 50. It's not quite in simplified radical form, but we can break this into the square root of 25, which is a perfect square, times the square root of 2 as an equivalent expression, and simplify it from here. Square root of 25 is 5, and square root of 2 will leave it as the radical for the exact value. So the distance between these 2 given points would be exactly 5 times the square root of 2. This problem further asks us, where is that midpoint? Where is that fulcrum or the balance point between these two? And to find that, the midpoint formula is x1 plus x2 divided by 2 and y1 plus y2 divided by 2. Using those same points that we had in the reference that I identified, we will find our x-coordinate by taking -3 the first x plus 4 the second x and divide it by 2. First y, which is 5, plus the second y, which is 6, and divide it by 2. Simplifying, a -3 plus 4 is 1/2. 5 plus 6 is 11/2. So the midpoint is at 1/2 and 11/2, which is 5.5. Because we were at a height of 5 and a height of 6, 5/2 makes sense for our vertical value, as does if you're looking for the average between the -3 on our x for our first point and 4 on our second one.